Hi guys. Sid. I'm the rendering chair and also the TSC chair. I am just going to give a quick overview of what went in from rendering perspective. The actual release notes covers all the changes. So here, if you can take a look, you can see everything from simulation, graphics, all the fixes, VR, XR, known issues. So there's a quite a fair bit here that has gone in the no script stuff, project export. Actually, these are the big heartbeat items here. But I'm not going to be going through over all of those. I am mostly going to be going over the just the rendering part. So the rendering changes are highlighted sort of at the bottom right here. Um, so I didn't plan anything special for this. I'll just kind of go over the editor and then point out where and how this all connects together for the rendering changes. So I'm just gonna, right. Okay, so can you guys see the editor?
We sure can.
Okay, perfect. Awesome. So the one of the big things that we added for this release was the mobile rendering pipeline. So if you open up the editor, normally you'll see the pipeline that's being run here under render pipeline. It's called main pipeline underscore zero because you can have main pipeline underscore one, or you can have multiple pipelines running in a scene or in the editor itself. So it's telling us that it's running the main pipeline, and we hooked it up to a C bar, and then C bar is actually called R. And then if you go into the console window, you can actually type it in R underscore render pipeline path, and it should show you what pipeline you're running. It's running passes dash main render pipeline dot lazy asset. This is an actual pipeline that lives under the passes um, directory. If anybody wants to know exactly, it's a data file, so it's all data driven. So it's an asset, and we load it as an asset. It's not hard coded inside the Atom code base. And you can, in theory, just switch to another pipeline. So if you want to switch to the mobile pipeline, you can literally just set the path. So in this case, I kind of copy pasted it here. So the render pipeline path, I'm setting it to passes dash mobile render pipeline dot az asset. This, if I just, so I'm going to press this. Sorry, I hit a bit. Um, the the under the hood, it actually switched. So you can actually see render pipeline is now mobile pipeline underscore zero. So nothing will change here. The difference between main and mobile is that for the main pipeline, every feature is enabled. It assumes you're running on a high-end uh, device with a forward GPU. Forward GPUs are different from tile GPUs. And the expectation is that it has ray tracing, it supports every feature under the hood. So that's why the editor uses the main pipeline. But you can, in theory, within the editor, switch to any pipeline. The game has main pipeline, low end pipeline, one for VR and one for mobile. The main and low end assumes a forward GPU. Forward GPUs are your GPUs that essentially all your PCs and Linux hardware uses. So anything with like NVIDIA 3 series, 2 series, 4 series, they're all forward GPUs. Anything that comes like a big unit. Anything that has a unified architecture that's really small. So think mobile, think tablets, think VR headsets, they all use tiled GPUs. And for those, we've built a mobile pipeline now. So that's the new version that's gone in and made significant improvements to the VR pipeline that actually we may discuss them more in a future update. The big difference between the tiled hardware and the forward hardware is just the way that they do rasterization. One does it in tiles, other one just does it as a full screen pass, and that has huge implications. Anyways, so as far as the editor is concerned, so now it's running the mobile pipeline. Any feature that is disabled or does an approximations kind of happens automatically, and if it's disabled, it just won't work. So if you try to do ray tracing, so like diffuse probe grid global illumination, it won't just work for the mobile pipeline. It will just sort of not like, so if you want to sort of, let's say, add a light here, I'm going to quickly throw in a light on a mobile pipeline. So if I add uh, an area light, so not a simple, not a, like a capsule light, it's probably not going to work. because that assumes the main pipeline. So but if so in this case for the mobile pipeline, one of the things that we added was it supports simple point light. So simple point light. So this works. You can kind of see the and see it kind of went up. It got lit up, and then it also supports simple spotlights. So I can throw in a spotlight, sort of move it up, turn it down. Here you go. So you got the spotlight hitting it. One of the things that we added for the and this is not just for the mobile pipeline. These are just extensions. We modified the simple spotlight to be better. So we added stuff called Bobo lights. So you can actually project a texture onto a spotlight. So if I literally just pick a texture here, I'm just going to just randomly pick. So here, so it's projecting that texture as part of the spotlight. So that was one of the big improvements that we added to the simple spotlight. Another one that we added was the shadow support. So before the simple spotlights didn't have shadows. So now you can actually enable shadows. And yeah, so it's actually getting occluded here. So you can kind of see everything gets a little bit darker. See if I can remove the, oh, anyways, this is fine. Oh yeah, here we go. So you can actually with the shadows, you can have all the functionalities work. We can even add filtering. The only filtering that will work is PCF. So that's the thing with the mobile. So if it was main pipeline, then all the filtering modes would work, ESM plus PCF. But for mobile pipeline, only PCF works. So you can just use PCF. And those are the new big things that we added on the lights side. Switch back to the point. So this is the point. But if you tried any of the area lights, they won't work. And that's by design because area lights are very expensive. So you don't want to have area lights on a mobile game. Same thing with the VR. Like you don't really want to have area lights on a VR game. ALU instructions are quite heavy for those lights, and they're not recommended. Pretty much your simple punctual lights are good enough for your mobile and VR needs. So that's one of the big things that we added for the light side. We also added fog. So I can sort of throw in, let's say, a component. I can throw in the fog. So deferred fog is now works for the mobile pipeline. I have the adding a post effects. So here there's fog, and as part of this work, we one of the recommendations was this is a linear fog. A lot of people didn't like linear and wanted a different, so we added two new modes. One was exponential. It may be hard to see the difference between, but you will see the gradual it changes, like the curve. So essentially the curve linears will be a straight line, whereas exponential square would be like an exponential curve. And if you're a technical artist, this was one of the big asks from Fog. So Fog works, and it has three new modes now, and they're all hooked up to a C-bar. So you can, in theory, set them up properly for your device by on load, so you don't have to set them every single time you load your level. So fog was one of the big things about it. Another one was decals. So if I was to just turn off fog. Right. Let me just delete fogs. I can throw in decal, and decals also work with the mobile pipeline. Right. My machine is a bit stuck. Oh, okay, that's not good. I've been playing around too much. I should have restarted it. I'll just restart it. So decals is oh, so this is my custom. It's supposed to be stabilization, but I have a bunch of local changes here. So the decals, we added a couple of things for decals. We added color to decals, and we added color factor. So I'll just kind of go over that as once the editor starts. So with a lot of these options, like when we added mobile in the pipeline, we had to be very careful with what features to add and what features to not add. On top of the features, we actually made a whole bunch of optimization improvements. So one of the optimizations that we made, improvements that we made, was shader options. Shader options, we added shader options for all the lights. So simple lights, so a simple point, simple spot. We added shader options for PCF filtering, shader options for decals. What does that mean? That means that if you want to create shader variants, so there's a whole different technology that exists with Atom, which is shader variant system. You can actually build shader variants where you have enabled or disabled just the features that you want. So if your level only uses simple point lights, then you can set up a variant where you just have variants for spotlights and not the point lights. So you can actually enable and disable stuff for variants. So this was really helpful to help lower down your ALU cost. That was one of the big optimizations that we did. We actually, this is not in the stabilization branch, but in the development branch, we actually added function constant support. So if by default you don't actually build the shader variants, it will actually try to build the perfect variant at load time. But that functionality doesn't actually exist in the stabilization branch. The last release, it was recently added to development. So if folks want to try that, that's an option. Okay, let's try to add decals here. So if I was to quickly add a component in the decal, and I can throw in a decal. Oh, here we go. Here's the decal, and um, you can actually, the things that we added for decal was we added a color, so you can add a color to it, so it can go red. There's a color factor. This essentially multiplies the decal color, so it actually kind of increases the value and kind of goes to white, which is black to white. So that was one of the things that we added. So we added shader options. Then we added particle support. So if I don't have a particle set up here, and that will take time to set up. I'm not going to add one, but if you had particles, it should work in Mobile Pipeline because you have support for transparent objects. Another thing we added was we added a whole bunch of tone mapping modes. So by default, there was only ACES. So now we've added Filmic, ACES, Filmic, and Reinhardt. Some are more expensive and some are very cheap. So Reinhardt is the cheapest here. By default, I think it uses Filmic or ACES Filmic. I actually forget. It's tagged into your, so you can actually so the functions already exist in the shader. So all you have to do is, if you want to use it, I think you just go to the mobile pipeline.pass file and then just plug in. And these can be updated at runtime too. So there's full support to update them from C++ side if needed. So that essentially takes care of your tone mapping. And it also actually added support for color grading. So I just realized, I think it should be in the whoever calls this, I think they have color grading support in there as well. So that was another thing that we added for the mobile. Oh yeah, Vortex Colors. Vortex Colors is kind of cool. Let me open up Material Editor. Vortex Color was a big ask. Basically, if you were to embed Vortex Colors data into your Vortex stream, the ask was, can we use that for lighting? So this was added by, so it's the best way. Okay. So if you open up any material, there is a section called Vortex Colors. They are disabled by default, but if your data has color information, you can enable it. And oh, okay, actually it does apply because it probably is picking up ones or zeros or something. And it does a multiply. So you can control these different modes. There's multiply, linear, like, lurk, overlay, and then there's a factor associated with it. So you can actually enable it once you've set up your material instance. I think we also added it in material canvas. Let me just try it. So it's not just, you can actually do like some form of a graph-based vortex color. So you can like modify it however you want using material canvas. So there should be a node here. Vortex colors, here you go. So you can bring over vortex colors. Okay. Base PBR, and then you can just attach it. And then in theory, they should work. I think it should be processing. Okay, yeah, it's doing. So once this finishes, it should, and then you can add like a material function. You can do sort of an add. I just want to make sure that this finishes. All right, 13.6. Yeah, it's actually building all the pipelines. You really only need main pipeline because that's what we're using. Okay, just last few more left. In theory, this should update. Oh, yes, it did. Okay, it's cool. So now it's using Vortex Colors. So you can actually kind of go from here to here, and then there, and then like update this on 5 or something. And then it should do a quick update, and then this should up. So anyways, so the point that I'm making is you can use Vortex Colors in material canvas as well. So that functionality also exists. Let's hope when I finish it, and then we can do a quick check. Another thing that we added was what else do I have? Okay, silhouette support. Yes. So let's just do a quick check with material canvas. There are ways to disable shader variance and make it run faster. Only have one pipeline, disable shader variance, and usually this is really fast. But because it's have everything enabled, I get. Oh, it did. There we go. Okay, perfect. So it does work. I mean, I didn't really prepare for this as well, so I was sometimes stuff breaks. So okay. Anyways, I'm gonna cancel this. Cancel this. These are the material canvas material editors. So let's try Silhouette. So Silhouette is essentially a new cool feature that was added. It was an ask for from Mad World, which is the game from Carbonated. So if you take, let's say, a shader ball and you clone it, duplicate it. Okay, perfect. All right, so now we have two shader balls. One is behind the other. And you should be able to apply a silhouette material, add a material component, and then let's modify it. So I think there was one added by default. Oh, here we go. Silhouette default material. Okay, here we go. So silhouette essentially gives you a bunch of modes actually. Let me open up material editor again. But the idea here is that with silhouette, you can have sort of like X-ray vision. You can do an outline. You can do a whole bunch of really cool stuff, which is like gameplay specific features. In this case, obviously, Mad World, the game needed it, so we ended up adding support for it. So here's the material. So you can actually modify it. So they have always draw, X-ray vision. There's a bunch of modes here. And then you can even play around with the color. So you can go red. I wonder if it'll update. Is there a save button? Yes, there's save. Oh yeah, it did. Perfect. So you can play around with transparency. Save that. Yes, and then you can see in the scene above it's getting transparent. There's also depth bias, so the outline should get thicker. Okay. Oh no, that's to make sure that it's ahead. This is the outline. So yeah, there we go. Okay. So it kind of looks funny. Okay, let me just reload everything. I don't actually know. So this thing has a whole bunch of features, and then this is the idea is that if you have walls and rooms and you want to see your friendly player or enemy player, and you want to some mode where you can see the outline, so this will help with setting that up. So that's the silhouette feature itself. It's really cool, and it's all driven through the material system. I'm sure I'm missing some pieces here of discussing. If I am, please, I apologize. Feel free to reach out on Discord if I'm missing some nuanced information. Another thing we added was lighting channels. So lighting channels is really cool. So if you look at a light, let's say this is a light. Oh, this is a decal now. Let me just throw in a light. And we essentially have lighting channels now. So it's a way to map a light to a mesh. So if you have a point light, so here's a point light, and I can say that this point light, this is all the white at the bottom. This is at the bottom. I can say this lighting only hooks up to lighting channel 1. So now it doesn't affect this mesh anymore because this shader ball, not this shader ball, this shader ball is only taking lights from lighting channel 1. So I bet you if I switch to lighting channel 2, what the hell? There. So now it's getting, I actually removed it from lighting channels. You can have multiple channels in your bulbs, but because the point light went to lighting channel 1, it only works if I enable it for this mesh. So it's just a way to map lights to meshes. And then that way it's really easy for artists to disable lights per mesh if needed. So given your scenario, a really easy way if I want to just exclude a light from a mesh. And there could be many reasons for it, and those reasons can be dependent on the gameplay, just the way the scene visuals are set up. So this was a really cool feature that was highly requested and added by folks. Another one was we added anti-aliasing. We already have 3 supports, but it's hooked up to a C-bar. So if you were to just type in anti-aliasing, oh, right, nothing is set up, but by default, you can see what anti-aliasing mode is set up. It's right here, resolution 124 by 776, MSAA 2x. So that means that we are using MSAA, which is multi-sample anti-aliasing, and it's 2x. So you can actually go to 4x or 8x. But in this case, if I want to go to temporal anti-aliasing, so you can just go equals TA. It's kind of flickering because I think there is an issue where with the TA anisotropic filtering doesn't work very nicely.
I think that's the grid component that causes that noise because it's more like a debug rendering feature. Maybe if you remove it, you don't see that flickering anymore.
Yeah, which is the ground?
No, the grid.
Where is the grid?
Above.
Oh, grid. Okay, here. Oh,
Yeah.
okay.
If you
There we go.
disable that. Yeah.
Okay, perfect. Awesome. That's a good tip here. Yeah, the grid is the problem with temporal anti-aliasing is that it doesn't work well with debug lines. And I think we just have to part of the reason is because it comes after the resolve and everything. It's the right before the copy to swap chain or UI. So it's too late at that point to take temporal aliasing into account. But it's an easy thing that can be fixed, which is something that was never a priority. So it does have anti-aliasing. We do have SMA as well. So you can actually see the TAs now. is being used. So it was TAA plus MSAA 2x. So I can go SMA. It doesn't add to it, but it will always try to use MSAA. The forward pipeline always has MSAA on. Now, if you can switch to a deferred or a different pipeline and you can get rid of MSAA, and actually you could modify forward pipeline to remove MSAA, but then you'll have to manually go into the pass file and update that. And update all the passes alongside with it. Because with MSAA, you write into MSAA render targets and then you do a resolve. So you have to take that into account. So MSAA is all inherently enabled in the forward pipeline, but then you can add more if you have some aliasing going on. So you can add SMA. The one that is that people prefer TA over SMA because SMA is a screen-based aliasing, so it will try to detect aliasing from your final texture, final render target output. So it will basically go, oh, okay, well, it has ways to detect patterns, and then these are aliasing patterns, and then it'll detect them, and then it will try to average them out. So it's the way it's screen based, but it's good, but it has limitations. Whereas temporal anti-aliasing uses the velocity buffer and previous frame, and uses that to help with the aliasing. Okay, so that's that. Another thing we added was, added ray tracing for skin meshes. So that's actually cool. So before, if I was to add, let's just add a diffuse point grid. So this one grid. Okay, so you can kind of see kind of lit up more. So diffuse probe grid essentially uses ray tracing. So at this time it's real time. So it's using ray tracing to add indirect lighting. So if you can kind of see, if I turn it off, it's less lit, and now it's more lit. Actually a better way if I just disable sun, and then I disable light, and I remove this light. I don't need this light anymore. Here, so you can kind of see the indirect lighting coming through. You see at the bottom. So right now it's just using IBL, which is a global sky. So it's just IBL lighting, and then if you add GI, it adds more to it. So this is sort of GI. So the thing that wasn't there before was that if I was to throw in let's see, actor. Then, oh yeah, Jack. I've definitely used Jack, and then I just sort of move my hair, and I should be able to throw in. All right, I need to add a simple motion. There's a place where I have to add. I forget. Simple motion is there, actor is there. Where do I attach the actual? Oh, motion. Here we go. Motion. Jack. Yeah, Jack. Depth. Here we go. So the thing that I wanted to show was that. Oh, no, it's not. Yeah, here. Motion. So the ray tracing is impacting Jack as well. So you can kind of see. So right now it's disabled. This is just the IBL lighting, and now if I enable it, Jack also gets hit by it. So it's everything is coming together. So you can kind of see Jack also gets lit up more from global illumination, and that wasn't there before. So we added support for the skin meshes. Another one that we added was the ray trace reflections for specular feature processing. Yes. So so another thing that got added was on the level side, we can add a component and specular reflections. And oops, I added 3 by accident. And in here, currently or before this release, the only way you could do reflections was through the screen space. It's called a hybrid mode. So basically, it was using screen space reflections, and then for areas that were behind the object, it would switch to ray trace reflection. So it actually was a hybrid of both screen space plus ray tracing. So we added expose the functionality to just go ray tracing fully from Strut. Now, how can we see this? To see this, I might have to make the ground reflective. Generate. Can I just update? Is there like a mirror? Yeah. Okay. So ground is a mirror. Now let's go back to, I want to enable reflections. Yes, there we go. So we enable reflections, and it used to be, this was the only way to do it, the hybrid. So it would use screen space and then switch to ray tracing afterwards. Let me just turn the Jack's motion into not be on all the time. Loop. Okay. So what we added was, so now it's just as ray tracing, and there are differences. Let's go in. You can kind of see, so this is the ray traced version versus if I was to pick the hybrid. I actually, you have to play around with the properties to kind of show the exact differences, but it should be similar. Like the whole point was that they shouldn't be off. It just means that the ray tracing one will be more accurate because the one approach is to use screen space and then switch to ray tracing in some cases, whereas ray tracing is just ray tracing all the way, like from get-go. So it should be more accurate if you can afford it, because ray tracing can bring with itself other performance issues and hardware issues. So you have to be careful with how you're using it. Another thing that was added was graphics tiers. Yes. So we introduced this concept of graphics tiers using the settings registry. So since people are not aware of settings registry, there's a lot of information online what it is, but I'm just going to quickly jump into the actual settings registry file, which was introduced. And there's all the code that supports it. But the idea here is that we added this concept of Q_general CVAR, and Q_general has 4 groups. Everything has essentially 4 groups, and then you can change them. These are just arrays, so you can just add the 5th or 6th or lower this. But by default, there's 4. And Q_general is the general CVAR, and then we've set up the one for graphics. So you can think of it as, you can set it up for like a different one for Q_physics or Q_simulation or Q_, very specific feature that you want to scale from a high-end device to a low-end device. So that's the idea. So everything from Q_general gets tied to Q_graphics, and then from Q_graphics, you can tie to all sorts of CVARs. So you have Q_shadows, you can tie to the anti-aliasing. Everything is hooked up. All the rendering features are in some way attached to some form of CVAR. There's CVARs that are associated with shadow filtering modes. CVARs is associated with just enabling, disabling features. So you can just set them here and then just say, hey, for tier 1, it's disabled, tier 2 is disabled, but enabled for tier 3 and 4. So, like low, medium, high, very high. So think of them like, oh, there you go, low, medium, high, very high. So this settings registry file doesn't really use it. Like it just sets it up, but basically Q_shadows is not really acting upon 0, 1. Like you have to then map Q_shadows to other CVARs related to shadows. But another one, here's an example of one that we added for iOS. And it's actually really cool because with iOS, it's a mobile device. It's a mobile platform. So for iOS, we actually also added this concept of device rules. So you can data drive device selection at load time. So we essentially just use regex expression so in this case, we're saying iPhone low is everything is iPhone 10 and 11, iPhone 6 to 8, and iPad 4, iPad 4 to 6. So it uses regex symbols right here, and then it will map it to Q general 0. That's what this thing is doing. So once you understand how this is set up, it's really easy to update. There's no code. Asset processor will update it, and then it will should automatically reflect. So this essentially maps these devices to setting 0. 0 goes to Q graphics 0. And here, so iOS has its own Q graphics settings. So its own Q graphics settings, it basically just has one. It's just updating the render scale. So it's basically saying that for the 0 tier, 0.7, 0.8 is the percentile of the native resolution. So the lowest tier is the 70th percent of the native resolution. 0.8 is the 80th. 0. That's how it goes. So this essentially impacts GPU performance. And the idea here is that the low iPhones will point to Q general 0, which will then point to Q graphics 0. So they will get 0.7. Medium, which is iPad 7, iPhone 12 and 13, and iPad 7 will get Q general 1, which will get Q graphics 1, which will get 0.8. And same thing with high, and then the very high, the Q general 3 will get 1.0. So that's essentially using settings registry and this tiering system to essentially drive scalability across your whole platform. So same thing applies to PC, although for PC, we haven't really set up anything because PC, usually for the most part, everything is good enough. It's only for mobile that you need to do this because you need these settings to be able to achieve, let's say, 60 frames per second or 30 frames per second. So I'm expecting this feature to be used more for mobile, but it can totally be used for PC, Linux, and Mac as well. So these are the list that I have, but let me just quickly take a look at the actual notes. Sorry, So we also added an optimized BRDF. This, if folks are interested, this is the way we do shading, apply physically based rendering. We added an optimized version of that for mobile. It's not being used for VR, but the plan is to use it for VR as well. It's in CPU optimization. It helps reduce ALU restrictions. We also added an analytical environment RBL approximation, but that is not currently being used. It's just there in case we want to get more performance out of the system. Everything else I've mostly gone over. I may have missed a few things in there. So yeah, we added a whole bunch of stuff around render scaling. We added support for render scaling across all devices. So mobile will take into account its landscape mode, portrait mode, and it will scale as needed. There's a whole bunch of initial scaffolding that has gone in for multi-GPU support, which is not in the release branch, but it's actually the full support has been added to the development branch. So if folks are interested in this, essentially multi-GPU support means that you can have a GPU workload being driven and executed by multiple devices. So not just one GPU, but like multiple GPUs. And then you can set up a pipeline where you're giving some workload to one GPU and then another workload to another GPU. And then instead of having one GPU doing the workload, the whole frame itself, you can share the workload. So just the initial scaffolding is there for in the release branch, but most of the work has been merged into the development branch. So you'll have to switch to development if you need this. I've already gone over silhouette feature, Vortex Colors, graphics tiers. We added support for geometry shaders for DX12 and Vulkan, intersection shaders. So this is for people who are looking at creating their own pipeline using geometry shaders or intersection shaders for ray tracing. Then the support is there now. We added, this is an optimization, basically for shadow mapping pass. You don't want to use all the shadows if you don't actually intersect with the shadow culling custom. So we added this culling support to skip unnecessary work on the CPU side. So it's a performance improvement on the CPU as well, a little bit on the GPU, but mostly CPU. Mainly because the shadow passes are really fast on GPU. Like reducing a few meshes is not going to have a big impact on the GPU. Already went over lighting channels. Enable, disable, this is just a simple improvement. Oh yeah, we added support for customized derivatives for texture sampling. So if you have a complete pass, you can use texture sampling. Better filtering for GPU models for Android. We added mesh shader. Yep. So this is mesh instancing was enhanced a little bit to make sure it can respect shader options. And we added improvements to the Vulkan RHI. So we added timeline semaphores, and also the ability to disable native windows. There's a whole bunch of optimizations that have happened that I'm probably not going to here for related to memory. And also we added ring buffer here. We actually added, there must be a CVAR setup to dump out information about assets, because sometimes you want to track memory usage. You can actually dump out all the loaded assets. So there's a CVAR there. We should probably have added that to the notes here, but we can look it up if needed. And I'm not going to go into the VR and OpenXR improvements at this point, but I'm sure Galip can go over this at some point in the future. But a lot of this work is actually really cool. If folks get a chance to try out Quest 2 or Quest 3 with the latest stabilization, you'll see a big improvement in performance. You'll see a big improvement in usage. So really excited on where the VR is headed for O3DE. That's about it. I think I covered everything. If I miss anything, just reach out to the graphics channel and I will try to answer as much as I can.